Okay, well, thank you very much for including me in this agenda. Again, my name is Jordan Clayton. I'm with the Utah NRCS Snow Survey Program. I'm going to talk very quickly about the snow program and just to provide a little bit of context there and about snow tell sites and what we measure. But I'll spend most of my time talking about the current conditions in the Southwest, which is what I think people came to hear. So just a couple brief slides about my agency and what we do. Again, I'm a branch of the USDA. Our mission is to measure the snowpack precip and other parameters in Utah's mountains. I'm focusing today on, of course, the whole Southwest, but I speak a little bit more frequently just about Utah. That's my jurisdictional area. We quality control the data that comes in from our snow survey, our snow tell sites. We create water supply forecasts for how much water we're going to get from that snow. And our key parameter that I'll talk a lot about is this snow water equivalent. If you're not familiar, that's frequently just referred to as SWE, and that's the depth of water that you would get if you melted the snowpack. And of course, in the West, in the Southwest as well, the majority of the water that we use comes from our snowpack. So obviously, we have a critical need for reliable, precise on-ground measurements of the water in our snowpack. There's a long legacy of measuring the snow in the West, started really by James Church in the early 1900s. We had these manual measurement locations that we still have some of in the West that were started around the 1920s called snow courses. In the 1970s, the NRCS transitioned to SnowTel automated weather stations for snowpack. Here's a picture of what a SnowTel site looks like. This is a typical configuration where you have an instrument tower that's got a snow depth sensor, has an air temperature sensor, and below those things is the snow pillow, which feels the pressure of the snowpack, which we can convert to that water equivalent. We also measure precipitation year round with that brown can on the right. We have an instrument shelter and, of course, in the ground, soil moisture and temperature sensors that I'll show some data for. We store just simple electronics. We store the data in data logger. We send out the message once an hour. I will mention that depending on which state you're in, you might have a different quality control regime that you're getting your data from. So, for example, in Utah, we're able to quality control the data every day, but we're only able to quality control the midnight daily values. The hourly values are also available, but just be warned that they're not QC'd. You can always reach out to us for more information on that. There's about a little over 300 SnowTel sites in the Southwest alone, so this is a really well-instrumented area of the country. Most of them have been measuring snowpack for more than 40 years, which is shown by these darker kind of blue into purple colors. All right, so really quick, that was like 4 minutes of background on what I do. So I'm happy to answer more questions about that later on, but let's jump into, again, the content for today's presentation, looking at some current conditions in the Southwest. And I'll be referring to these four regions. I won't be really talking about the California region, even though it's on the map, but we'll talk about the upper and lower Colorado, Great Basin, and the Rio Grande, the two-digit hawk areas. And for each of these, I'll be showing a lot of these kinds of graphs. I apologize if you've seen a lot of these graphs and you don't need this explanation, but if these are new to you, what's shown here is for this particular region, what the current conditions look like with the black line. So that black line that's a little bit below the green line there is the current condition for the upper Colorado region, which is circled in red. And then you can contextualize that by looking at the green line, which is normal for this time of year. And the range of colors in the background are the statistical percentiles. So what this shows is that for the upper Colorado region, the snowpack, here we're looking at the snow water equivalent. So the water equivalent of our snowpack in this area is between the 0th and the 10th percentile. It's at about the 5th percentile for the upper Colorado. Obviously not the domain that we want our snowpack to be. I'm going to jump around to the other four regions, or the other three regions now. For the lower Colorado, very similar story, about the 18th percentile. I like to use percentiles instead of percent of normal this early in the snowpack season because it's a little bit more meaningful. There's actually been some loss of SWE in the Southwest, in the lower Colorado, which is not something we like to see. Great Basin is actually setting records right now for how low its snowpack is. You can see we're outside the range of previous observations. The black line is below the range that's shown there. The Rio Grande is a little bit better, about the 17th percentile, and in that yellow instead of in the red. So that's, I suppose, a little bit more positive. We could map this out by basin. Here are the Huck 6 basins across the Southwest, and they're colored by percent of normal. And here normal is the median for 1991 to 2020. where everything that's in red is below 50%. You can see, hopefully you can resolve the rest of the numbers in the legend in the left there. But obviously red and orange are the worst colors to be on this map, and that's what we're seeing across the Southwest. This is as of yesterday. If we dive into a little bit more of the Huck 8 resolution, we see a couple areas do jump out as doing a little bit better. South Central Colorado, for example, and portions of New Mexico, sorry, Arizona and Utah have had a little bit more success, but by and large, the story has not been positive thus far. Now, I wanted to break this out by elevation band. Normally, when we get a slow start to our snowpack season, when we've had more precipitation than we've had snowpack, we still see a positive start at 10,000 feet or above, but we're not seeing that this year. We do have a couple sites that are performing a little bit better, as you can see on this map where there's green and blue, a little bit more yellow on this map. But when we go into the lower elevations, here's 9 to 10,000, and here's all the sites below 9,000 feet. Again, just looking at our mountains in these areas. It may look striking that it's more red, but it's really not as different as we would like to see. And part of why that's been happening is that we've had, unfortunately, snow lines that are very high elevation this winter so far. So while the precipitation has been coming, the snow has not, and we've just been getting liquid moisture instead of solid, and that's why their 10,000 foot and above area has not done as well. Let's look at the individual snow-tell sites on this diagram, on this map, and you can see for each one of these how far it is away from its normal for this time of year. This scale is in inches. So this is the amount of snow water equivalent departure from normal in inches. And when we get into those darker orange and red colors, we're talking about 3 or 4 inches below normal, which is a lot of snow water to be below for this time of year. So we do have time to catch up. I've been saying that to the media. I do think that there's possibility of catching up, and I'll talk more about that here in a second. But it's definitely not the start that we wanted. In fact, we're actually setting an unfortunate number of records right now, which is what's shown here. Everything that's red on this map is a record low for snow-tell sites, SWE, for this time of year, where it's orange is the second lowest. So this is a really large number of sites that are setting record lows right now. Definitely concerning. Now, I wanted to put these diagrams in. I don't usually show these diagrams, but I've labeled them on the upper right with optimism stamps because I think we need to hold on to some kind of hope here. And what's shown here is 4 different states. This is only done at the state level. So I'm going to start with Utah, and then I'll move to the other 4 corner states. And to help you understand here what we're looking at, what's shown here is how the state's snowpack was doing on this date, each one of the years that's on the bottom. And it's sorted from worst to best. So I don't know if you can see my mouse, but where you see that red arrow, it's pointed towards 2026. That's this year. That's how Utah is doing right now. And you can see how it was doing for this date in all those other years. What's also shown are where the state peaked for that particular snowpack season. The green lines provide some context. The green line on the bottom shows the median for this date, going back in time so the median snow water equivalent for this date going back in time for the state of Utah. And the upper green line shows the median peak going back in time. And I guess I show these and I call them optimistic because yes, 2026 right now, as you can see, is the second worst for this date going back in time. But we have 3 years, 1999, 2000, and 2009, that were almost as bad. They're just a little bit to the right. And they finished right around that upper green line in terms of their peak snowpack. So they finished at or above normal peak, and that's encouraging that hopefully we can turn things around in Utah. Let me dive into the other states as well. Here's Arizona. We're at about the 9th worst winter for Arizona going back in time. 2024 was worse and actually finished above normal, so that's encouraging. Unfortunately, that's the only one that's encouraging, but I'm trying to be positive here. Colorado, this year is about the 3rd worst on record. But we did have 2000 that was worse and finished right about normal. And so that's a reason for optimism there. And then for New Mexico, similar story. This is the 6th lowest on record for the state. 2024 was only a little bit better and actually finished above normal. So there's, I suppose, reason to be hopeful there as well. And staying positive, let's talk about the precipitation in the region. I know I only have a few more minutes, so I'm going to kind of blast through these pretty fast here. I don't want to take any time from Curtis. But when we look at the 4 areas, upper, lower Colorado, Great Basin, and Rio Grande on the right side, We see the black line is right about at the green line or above it, meaning that we are at or above normal precipitation for all four regions, which is obviously good. Regionally, we can see that on this map as well. The individual snow tells and the basins are colored by the same percent of normal coloring, and all are doing pretty well for the most part. Soil moisture is also a positive story. You can see the percentiles that I've labeled above each one of these diagrams, and you can just really quickly see that the current trend for soil moisture in the mountainous areas in these four states, excuse me, four regions, is really positive. And why we care so much about that is we're looking at all that snow water that's stored in the snowpack as a reservoir. And once all that snow melts, we need the delivery of all that water to be efficient. When we have above normal soil moisture, it tends to promote efficient runoff from that snowpack in the spring. And so instead of losing a lot of that soil water, excuse me, snow water into the soil, we do tend to get a larger proportion of it when we have wet soils, and that probably won't change through the course of the winter much. And so this is a positive part of the story. Here's the maps of the soil moisture distribution throughout the Southwest. So a lot of green, which is close to normal. You get into those darker blue colors, it's well above normal. Quickly, air temperatures have, I think, quite obviously been above normal. You can see this is just for the lower Colorado, but the map, excuse me, diagram looks the same for all four regions. It's been setting records or close to it for all four regions. And I'm going to jump past reservoir storage, just jump to this slide just so I don't take up too much more time. This is the percent of reservoir capacity in all the sort of measurable reservoirs through the Southwest. Where we get into those darker colors towards blue, we're looking at closer to full. And then obviously into the yellow colors, we're looking at closer to empty. And so this is how things look as of the beginning of December. And then just a couple of quick comments about the larger water bodies in the Southwest that we are concerned about. I spent a lot of time talking about the Great Salt Lake here in Utah. The Great Salt Lake current lake level is at 4191.5. We have really good folks at the DNR here in the state of Utah that have put together kind of an optimal range for all the different functions that are listed in the top left there. They put together this cool diagram. And you really need to get to about 4198 to be at the bottom end of the optimal range for the lake. So we're a little bit more than 6 feet below the bottom end of that optimal range, which is a lot of water that needs to be put back into the Great Salt Lake. You can see the red line on the time series graph from the USGS showing where the current lake level is compared to going back to the 1800s where the lake has been. And the snowpack for the Great Salt Lake isn't looking great, but we're hoping that that turns around. Similarly, for Lake Powell and Lake Mead, they're only about 32% of full for Lake Mead, about 29% of full for Powell. You can see some different predicted outcomes, which is shown by the red, black, and green on the bar chart. That's the minimum, maximum, and most probable outcomes for what the lake might receive this year. Excuse me, Lake Powell might receive, and not as high as we're hoping for that to be. And then this is just I pulled from some recent research showing, unfortunately, pessimistic trends for, on the left side, decreases over time in high mountain snowpack, and on the right side, decreases in time for runoff and precipitation, and increases in time for temperature, which is probably isn't a surprise to anyone on this call, but here's some interesting data reinforcing those trends. I know we're saving questions until the end, and so I wanted to just at least pause for a second in case you wanted to grab a screenshot of that QR code that takes you to our homepage, but I will also be on the call at the end and happy to take questions then. Thank you again.
Okay, thank you so much, Jordan, and I'll pass it over to Curtis.
All right, I'm gonna get my screen sharing set up here, so pardon me for just a moment. I have to replace current share. Can you folks see just my normal slide deck here? The opening slide, rather than the presenter view?
Yes.
Okay, very good. Thank you. All right. Thanks for a great presentation, Jordan. I'm going to be building off of that presentation that you just gave in some areas, but I would encourage folks to, especially on some of the snowpack and hydrology data that we're going to look at, it's going to be a lot of repeating what Jordan just talked about, and certainly refer to his expertise and diving into the data from the first talk, because he went into a lot more detail in some areas than I'm going to in this. So anyway, thanks for that, and thanks for the introduction, Jackie. My name is Curtis Regante. I'm a climatologist here at the National Drought Mitigation Center at the University of Nebraska here in Lincoln, and I'm one of the United States Drought Monitor authors as well. So today I'll be going through just a quick update of what the drought conditions or lack thereof look like in the Southwest United States, and then we'll take a brief look at current and recent conditions in Hawaii and the US affiliated Pacific Islands as well. Okay, so this is a quick look at the current map released. It would be yesterday, Thursday at 18th. So this is a snapshot of conditions on the morning of Tuesday, December 16th of this week, created by my coworker, Dr. Lindsay Johnson. So for anyone, I think most people in the room are probably familiar with the US Drought Monitor, but in case you're not, it's a weekly map of drought conditions and their severity and coverage and timescales associated with them across the United States. And more specifically, this map is updated weekly, and the colors that you see on the map, kind of building off what Jordan just told you, you don't want to see the more red, warmer colors. What that means is lower percentiles of data or more rare levels of drought for each local area. So generally speaking, we have seen a significant amount of improvement, though with some caveats that I'll get into that kind of refer back to what Jordan was talking about, a bit of a mixed bag across the Southwest over the last couple months, with some areas receiving a hefty amount of precip. That said, we're still looking at widespread areas of severe and even a few areas of extreme drought that you see in that red and tan colors across New Mexico, Arizona, and then parts of Utah, and then across parts of the Hawaiian Islands as well. So zooming in on the Southwest states, and you can, so yeah, and just a quick look at the drought conditions in the Southwest currently. We are looking at still fairly widespread, severe, and even a few areas of extreme drought, but again, much better than we saw a few months ago. And so we'll go through what the weather conditions have been like the last couple months that have led to these improvements. So first, I'd like to show a map here just from the CoCoRaHS data network. Again, this is Community Collaborative Rain, Hail, and Snow Network. This is a citizen science initiative where people can collect daily precipitation data and submit that data. And so what I want to point out here is really across, especially like Western California and Southwest California, but even into parts of Southwest Colorado, Central Arizona, and a few other areas, we have seen widespread precipitation amounts since the beginning of the water year of at least 5 inches. This is not differentiating rain versus snow here. And a few areas that have even seen as much as 10 inches of liquid water equivalent precipitation. So now I'm going to show some maps from PRISM from Oregon State University. You can find these maps at the URL below, but again, these are courtesy and copyright of PRISM system at Oregon State. So these are, and we have something in the chat. That's not what I wanted to do. Yeah, so these, what we're looking at is the percent of average precipitation, I believe normal precipitation for the month of October of this year. So we did see above normal precipitation across much of Arizona, parts of California and Southwest Colorado, and Utah and Nevada during October, but we did see below normal precipitation in southeast parts of New Mexico and other parts of southern New Mexico. Make note of that. Moving forward into November, I can advance the slide here. We did see below normal precipitation in parts of northeast Nevada and northern Utah, but otherwise, the thing that kind of jumps off the screen here is widespread, well above normal precipitation across much of California, especially the southern half of the state, southwestern and south central Nevada, central and western Arizona. We did again see a little bit of below normal precip in southeast portions of New Mexico. And then so far in December, things have really dried out for the first few weeks of the month in most areas of interest. So again, consistently below normal precipitation over the last few months since the beginning of the water year in southeast New Mexico, but many in other areas have seen above normal precipitation. However, as we'll see, this has improved soil moisture and a few other quantities fairly well. However, the effect that's had on snowpack and the water that's being stored up in snowpack does not look as favorable. So putting together all these precipitation numbers over the past few months this is a statistic called standardized precipitation index. To simplify this, all this is really doing is looking at for all periods from October 1st through December 18th, how does the precipitation amounts at these different points that you see on the map compare to what's normal for that period? And any cool colors that you see on the map are well above normal precipitation for that time period. So again, we've seen above normal precipitation across much of southern Nevada, southern California, Arizona, parts of southwest Colorado, parts of southern Utah. A few other areas of Utah, northeast Nevada, and southeast New Mexico have been below normal over that period, though. What the above normal precipitation in some areas is done to stream flow averages collected by the U.S. Geological Survey. For the most part, this is looking pretty good over the past month or so of data. These are percentiles that you see for the 28-day averages as of this past Tuesday when the most recent drought monitor map was made. I'm going to show, excuse me, I'm going to show some soil moisture estimates here. Again, all this expressed as percentiles. This is just an ensemble of different soil moisture models from the NLDAS2 system and showing pretty decent soil moisture conditions in most areas with some local exceptions in parts of Utah, Nevada, and southeast New Mexico. Looking at gray space, so NASA gray space root zone soil moisture data. Again, we're looking at mostly wetter soil moisture in parts of California and Arizona and portions of New Mexico now, though with some areas in eastern and southern Nevada, Utah, and southeast New Mexico still showing fairly dry soil moisture conditions. This is data from NASA's Sport Soil Moisture, looking at the top top meter of data, and we're looking at mostly above normal soil moisture, with some areas of below normal soil moisture in eastern Nevada, portions of Utah, and southeast New Mexico, and west central New Mexico that we'd seen in some of the other products. Quickly, I'm going to show the National Drought Mitigation Center has been producing machine learning assisted blends of some of these different types of data products that we put into the US Drought Monitor. And so we've broken this up into short, mid, and long-term data sets. So just quickly running through this, again, we're looking at kind of drier conditions in the short term still across the southeast corner of New Mexico, parts of east central Nevada, and central into northern Utah, whereas Arizona, southern Nevada, and California are much wetter than normal in the short term. That's especially true as we go out to midterm and kind of look more back across the water year that we've started so far. And then the long term, we see kind of a mixed signal for that in parts of California and Arizona, with much of Utah, western Colorado, and then southwest New Mexico and southeast and southern Arizona still showing up as somewhat dry in the long term. So takeaway, short-term drought conditions are pretty good in many areas compared to what they had been, with a few exceptions. The long term is a bit more of a mixed bag. And so since October 7th, these are the category changes that we've seen on the US Drought Monitor maps. So we've seen significant improvements across much of California, Nevada, eastern Utah, Arizona, and western New Mexico, whereas we've seen one and a few two-category degradations in New Mexico, especially the southeast corner of the state. So in case I've painted a bit too optimistic of a picture on what's going on in the Southwest right now, I'm going to return to a few of the less optimistic things that Jordan was talking about in his presentation. So again, we still do see somewhat widespread drought conditions, some significant drought conditions across parts of the Southwest. So over the last week, we've seen above normal temperatures. These data maps from the High Plains Regional Climate Center across much of the region, which has likely not helped with snowpack in different areas and would have increased the atmospheric demand or atmospheric thirst for the time of year. These are the same SPI data I was talking about earlier, just looking at precipitation anomalies, but now going back a full 12 months from this past Tuesday. And you still see some pretty significant deficits occurring in parts of central and western Colorado, across much of the state of Utah, parts of east central Nevada, and in southeast Arizona and southwest New Mexico. So where you see the red and maroon colors, those are really significant deficits on the order of about 2 standard deviations or worse for the time period in question. Looking at deeper groundwater data from the NASA GRACE product, we are looking at still significant deficits likely occurring and deeper soil moisture into groundwater data across much of the Southwest United States, though this has improved in some areas. And again, looking at SWE data, and this is a kind of a recap of what Jordan was talking about earlier, but as of the end of the day yesterday, we are seeing well below normal SWE. This is percent of median across much of the Southwest region. And on a station by station basis, looking at the snow water equivalent percentiles, with a few local exceptions, we are seeing very low percentiles across much of the region here. So, quick look at Hawaii and the US affiliated Pacific Islands here. So, we have seen some recent improvement in the northwest part of Hawaii, especially on Oahu and Kauai, but we are still looking at significant drought occurring in the eastern portion of the Hawaiian Islands, especially on Maui and the Big Island. So in the last 10 weeks, we've seen some degradation in the central part of Maui and on the western part of the Big Island, and we've seen a mix of improvements and degradations elsewhere. Just looking at the last 14 days, the improvements that have occurred on Kauai and Oahu have been driven by above normal rainfall that we've seen on those two islands over the last couple of weeks, but we've still seen pretty dry weather compared to normal in some of the eastern portions of the state. And so again, no improvements there, while we've seen improvements on the windward side of Molokai and then on Oahu and Kauai as well. And then finally, a quick look at the US affiliated Pacific Islands. We're free of drought across the whole region, mostly free of abnormal dryness with a few exceptions. Rota and Guam have had significant rainfall over the past week or two, whereas Saipan and Tinian are experiencing short-term abnormal dryness. Not a lot of impacts have been reported there, at least as of a few weeks ago, but they've remained pretty dry this week. The Federated States of Micronesia have been fairly wet over the past week. The Republic of the Marshall Islands has been a little bit drier, though we've only seen short-term abnormal dryness right now on Kwajalein and Utah. So we're going to come back over to the continental US here and go over some quick short-term outlook information. So these maps here, the next couple I'm going to show are from the National Weather Service Weather Prediction Center. And we are looking at right before Christmas holiday, December 23rd through 25th, significant chances for heavy rain in parts of California and some heavy mountain snow in parts of the Sierra. And a look at the day 1 through 7 QPF. So this is through 0Z on Saturday, December the 27th. We are looking at, in terms of liquid equivalent precipitation, some pretty hefty amounts across parts of California, northern Utah, and Nevada. You can see that on this forecast map here. Now, some outlooks from the National Weather Service Climate Prediction Center. The Southwest region's generally looking warmer than normal from December 26th through the beginning of the new year. Though we're also looking at likely above normal precipitation, especially the further west in the region that you go. Quick look at Hawaii. We're probably looking at above normal temperatures and precipitation there. Looking towards the longer term outlook. Now, these new seasonal outlooks were just issued yesterday, and they are leaning towards above normal temperatures. So probably above normal evaporative demand from January through March, as well as unfortunately below normal precipitation across the southern part of the Southwest region. So translated to the outlook for the US Drought Monitor, this does mean drought development is likely to occur across the southern edge of Nevada, western Arizona, southeast California, and much of southern Colorado, and the rest of New Mexico, where drought's no longer occurring. We do see some chances for improvement or removal of drought in parts of Maui and Oahu and Molokai. So with that, I will give a shameless plug for the next US Drought Monitor 101 webinar and question and answer session that we'll be having on February 12th of this coming year. Please feel free to register and reach out to myself or one of my colleagues listed below if you have any questions about the US Drought Monitor. So